All right, everybody, today we are going to start to talk about our mini unit on functions. A function is basically a set of ordered pairs, and remember ordered pairs are always x comma y, such that for each x value, there's only one y value. So this is our big focus for this unit we are going to be working in this week a bit. Domain, if I ask you to find the domain, it's the set of only the x values in the ordered pairs. And if I ask you to find the range, it's only the y values in the ordered pairs. So these first few examples are going to be quite easy because you literally just have to list your x values for your domain and your y values for your range. So the domain of set A would literally be only my x values, 0, 2, 3, and 10. For the range, my y values are 1, 7, -6, and 22. So why don't you try to do part B, pause the video, list your x values for your domain, the y values for your range, and press play when you're ready to check your answers. And as you can see, I only listed my x values of my ordered pairs for the domain and only the y values of my ordered pairs for the range. For problem 2, evaluate each function with the given input value. So all you have to do, and you already know how to do this. This is basically the plug and chug that we've been talking about since the beginning of the year and what your math teachers talked to you about last year. Anytime they give you an input, that is your x value. So you are basically just plugging in your x value and finding out what your corresponding y value would be. So for example, y equals 2. Instead of x, I'm plugging in my x value of 7 minus 1. So y would equal 2 times 7 is 14. Minus 1 gives you 13. So my output, or y, would be 13. The next one, same thing. Even though it says f of x, you are just literally doing the same thing. That's sometimes what they use to denote a function, but we are doing the same thing. So I would say f of x is equal to -3 times 8 plus 2. And if I solve this using order of operations, I would have -24 plus 2. And my final answer, -24 plus 2, is -22. Why don't you try this last one on your own? Like I said, it's just plugging and chugging, and then press play when you're ready to check your answers. So for this last problem, I plugged -5 in for my x value. When I multiplied those because of order of operations, I had -50, and 15 plus -50 is -35. So I hope from this page, at least from the bottom part, we basically already know how to do this. You are plugging in your inputs. Okay, there's another way to determine if I give you a table or a graph if it is a function. So the first thing we're going to do is talk about a table. So for a table to be a function, each x value relates to only one y value. So basically you only have one output, which is your y, for each input x. So let's look at this table. I have an x value of -5, which only goes to one y value. An x value of 4 only goes to one y value. An x value of +5 goes to one y value. And an x value of +8 only goes to one y value. Since each x only goes to one y value, yes, this is a function. It's all right if you don't quite understand that at this point because I'm going to show you situations that it works and situations that it does not work. So remember, for it to be a function in a table, each input, remember which is your x, has exactly one output, which is your y. Another way to determine if a table is a function, we could literally graph it, which I'm going to be doing right here in a moment. But to talk about graphing before we actually do it, if I give you a graph, it's actually easy to see if it's a function because it has to pass something called the vertical line test. Basically, the graph is a function if you can draw a vertical line anywhere on the graph so that it hits the graph in only one spot or one location. And that's what I'm going to show you now. So right here, if I would graph my data from this table up here, so if I graph -5, +5, remember it's hard to do in this program, but we're going to try our best. If I graph the ordered pair 4, 4, 5, 5, and I'm just going to estimate where 8, 8 would be since I ran out of room. So as you can see here, this is my data. If I draw a little line. Now, what I'm about to do in green is draw vertical lines, or you could actually put your pencil and keep going down. Do you see how it's only hitting my line in one location? No matter where, my green vertical line is only crossing my yellow graph in exactly one location every single time. Since it passes the vertical line test because it only hits it in one location per vertical line, yes, it's a function. Let's look at the one down here. So first we can look at the table. -3 is going to a y value, +3 is going to a y value, and -2 is going to a y value. A lot of kids get confused on this because they see the y values exactly the same. But remember, for it to be a function, it has to have a different x value for each y value. So yes, this is a function, and I'm going to graph these for you over here. So if I graph the point -3, 7, which would be right here. If I graph +3, 7, and the last one on that table below was -2, 7. Here's my line. Now remember, in green I'm going to draw my vertical lines. No matter what, no matter where I would put a vertical line, it's only hitting my purple graph in one location. For example, it's hitting it here, 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 and so forth. So since it passes the vertical line test because it only hits it in one location, yes, it's a function. So on your PSSAs, it might be easier for you to look at the table or use graph paper and graph it to see if it passes the vertical line test. Next page. If we try this one, this table is not a function because you see how we have the same x value repeated. Since we have the same x value repeated, no, this is not a function. We could graph this as well. And remember, in our table, it's not a function because the -3 goes to more than one y value. We could graph this data. So if I graph -3, +4, -3, +5, -2, 6, and -7, 7, which I'm going to roughly put right here. So if I would connect these, I'd have something like this. So if I start drawing my lines in green, my vertical lines, it's passing the vertical line test so far. However, when we get here, do you see how it crossed here and here? That's why this is not a function, because it did not pass the vertical line test right here. It hit my graph in more than one location. I want you to try the table below. You can either look at the table and see if it's a function or not, or graph it and see if it's a function or not. When you're ready to check your work, you may press play. So pause the video now, please. If you check your work, you will see that this is not a function because the number 5 is literally going to every single value. So 5 goes to more than one y value, and if I graphed it like I did here, you'll see my points in blue. I drew a line through them, and actually, if I drew a vertical line, this is definitely not passing the vertical line test because it's hitting in more than one location. All right, I want you to try this page on your own. I want you to draw vertical lines, and remember, if your graph is only hitting the vertical line in exactly one location per vertical line, yes, it's a function. If it does not, then no, it is not a function. So pause the video, and whenever you're ready to check your answers, you can press play. And as you can see here, if they passed the vertical line test and they were a function, I put that in blue. If they did not pass the vertical line test, I put them in yellow. This one is not a function because it's hitting it, the same vertical line, in more than one location. Same with this, and same with this. Remember, if it does not pass the vertical line test, it is definitely not a function. For this page, we are using the input, which is the x of the function, to determine the output y. We sort of did this on the first page. So y equals -5 instead of x, because that's my input. I'm plugging in -4 plus 9. So y equals 20 plus 9, which is 29. 29 is my output. For the function table represented below, what is the output when x is equal to 11? So you could guess and check or try to find a different pattern to fill in the blank, or you could write equation, which that is what I'm going to do. So remember to write an equation to find your slope. You can pick your two ordered pairs, so I might just choose this ordered pair and this ordered pair. Remember, you subtract your y's and your x's. Y's always go in your numerator. So if I do that, I would have 5 minus 9 divided by 2 minus 4. 5 minus 9 is -4. 2 minus 4 is -2. And when I divide those, I get a positive 2. So positive 2 is my slope. So far I would have y equals 2x. I have to find my y-intercept. So I could work backwards in my table to get to the 0. If my slope is a positive 2, and if I'm working backwards, the opposite of adding 2 is subtracting 2. So leaving off in my table, 5 minus 2 would give you 3, and 3 minus 2 would give you positive 1. So positive 1 is my y-intercept. So now I can plug in my input of 11. So I would have y equals 2 times 11 plus 1, which would give you 22 plus 1, and your final answer would be 23 for your output. Same thing for this one. Y equals -12 times 0 plus 88. I'm solving for my output. So 0 plus 88 is just 88. For the function graph below, what is the output when x is -3? So make sure you start on your x-axis. Go to when your line, go to -3 on your x-axis, go to when it touches your line, and then go over to find your output, which is, in this case, -3. Now this time we're doing it a little bit different. Use the output, which is your y, to determine the input, which is your x. So make sure you're plugging it for your output. So instead of y, that's my output. So I would say 60 equals 2x plus 50. And now this goes back into solving equations, which is what we did at the very beginning of the year. Your goal is to isolate the variable x and get it by itself. So the first thing I would do is subtract 50 from both sides. This would leave us with 10 is equal to 2x, and the opposite of multiplying by 2 is dividing by 2. So 10 divided by 2 is 5. Remember, if I'm going too fast, you can always pause the video, rewind it, and whatnot. So for the function graph below, what is the input when the output is 30? So remember, the output is your y. So I'm going to go to my y-axis at 3, go to when I hit my line, and then down to find my input. So in this case, my input, or x value, is positive 4. So once again, I need to find my missing value. In order to find that, one way would be to write your equation. So to find my slope, I'm once again going to pick two ordered pairs. I subtract my y's in my numerator, my x's in my denominator, and remember this formula I just wrote down is on your formula sheet. So I would have negative 19 minus 1 divided by negative 10 minus 0. Negative 19 minus 1 is negative 20. Negative 10 minus 0 is negative 10, and when I divide those, I'll get a positive 2. This one I don't have to solve for my y-intercept because it was given. Remember, when x is 0, whatever your corresponding y value is your y-intercept. So my equation would be y is equal to 2x plus 1. But I'm not done yet. I have to plug in this value. This value is my y value because it was in my y column. So 41 is equal to 2x plus 1. I'm going to solve this just like what we did at the beginning of the year. So I'm going to subtract 1 from both sides. I would have 40 is equal to 2x. Divide every single thing by 2, and in this case, x, or my input, would be 20. Right, so for the next set of problems, it's asking you to determine if it's a linear or nonlinear function. If it's linear, write an equation. Remember, our linear equations are of the form y equals mx plus b, where m is your slope and b is your y-intercept. So for this first one, this is definitely linear for number 6. And why? Why? Because it has a straight line. So remember, to find your slope on a graph when you have a straight line, you pick any 2 points you want and build your rise and divide it by your run. So my rise, if I would have counted 1, 2, 3, 4, 5, 6, my run is 1, 2, 3. So if I take my rise, which was 6, and divide it by my run, I'm going to get a slope of 2. My y-intercept was actually where my line crosses my y-axis was down here at negative 3. So that was my b value. So if I ended up writing my full equation for this problem, I would have y equals 2x minus 3, or you could have said y equals 2x plus negative 3. Alright, another way, remember, to see if something is linear or nonlinear, you can do change in y divided by change in x. So from 8 to 6, I'm subtracting 2. From 6 to 2, I'm subtracting 4. From 2 to negative 2, I'm subtracting 4. And from negative 2 to negative 4, I'm subtracting 2. So for my changes in x, from negative 4 to negative 2, I'm adding 2. From 2 to 0, I'm adding 2. 0 to 2, I'm adding 2, and from 2 to 4, I'm also adding 2. So that, remember, to see if this is linear, you do change in y, which I'm just going to use the triangle symbol, divided by your change in x. So if I would take negative 2 and divide it by positive 2, I would get a negative 1. Let's try the next set. Negative 4 divided by positive 2 would give me a negative 2. Since these numbers do not match up, they are not the same value, no, this is non-linear. So this is a non-linear function because they did not have the same rate. And since it's nonlinear, for this year, we are not making you write an equation. Okay, so for the next one, just to see if it is linear or nonlinear, I'm going to do the same thing like I did above. Or remember, you could pick ordered pairs and find your slope that way if you wanted to. So from 10 to negative 2, I am subtracting 12. From negative 2 to positive 16, I am adding 18. From positive 16 to negative 5, I'm subtracting 21. Change in x. From 3 to negative 1, I'm subtracting 4. Negative 1 to positive 5. Whoops, that's subtracting 4. Negative 1 to positive 5, I'm adding 6. And from positive 5 to negative 2, I'm subtracting 7. So to see if this is linear, I do change in y, negative 12 divided by negative 4, and I'll get a positive 3. Let's try the next set. 18 divided by 6 gives me a positive 3. Let's make sure it works for the rest of them. Negative 21 divided by negative 7, I get a positive 3. Since I got the same value, this is definitely linear, and 3 is my slope. So I would have y equals 3x. So now you have to find your y-intercept. So there are different ways to do it. Remember, you could try to find the 0 in your table. So 0 could be right here. So if my slope is a positive 3, let's do negative 2 plus 3, which would give you a positive 1. So positive 1 is my y-intercept. Remember, if you're still not sure how to get slopes or y-intercepts, you need to refer to Mr. Katay's video on the linear review. Alright folks, we are going to actually skip this page for now. We may go back to it a little bit later, but if you go to your next page, it says, do the ordered pairs satisfy the equations? So this, once again, is all about plugging and chugging. Remember, in an ordered pair, it goes x, comma, y. You are literally just plugging in your ordered pairs and see if the values from your ordered pairs and see if they match. So instead of y, I'd plug in negative 5. Instead of x, I'd plug in 3. Now I'm going to see if both sides match. So negative 5 is on this side. 2 times 3 is 6. Minus 1 gives you a positive 5. It's a negative 5, which is on my left-hand side, and positive 5 match. No, they do not. So this ordered pair would not work or satisfy the equation. So I want you to do B through E. Remember, if they match, they work. If they do not match, then no, it does not satisfy it. So pause the video. Whenever you're ready to check your answers, feel free to press play. So if we start to look at our answers, B is definitely yes because both sides were equal to negative 10. C is not, it does not satisfy because 24 would not equal negative 18 when I would simplify that side. D, yes, because 12, when I simplified this side, I would also get a 12. And E works because 42, when I would simplify this side, I would also get a 42. So I hope that helped you remember how to see if an ordered pair satisfies an equation. And if we move on to our last page, this is where some of you got confused on your PSSA practice test when we are comparing comparing rates, y-intercepts from tables, graphs, verbal descriptions, and so forth. So let's look at the first one. Function E is represented by the following description. The value of y is equal to the sum of x and negative 5. So the first thing I'm going to write down is my equation for E, for function E, which it says the value of y is equal to the sum, which means addition, x plus negative 5. Then it says function f is represented by the following table. Compare the rates of change and y-intercepts. So in order to do that, I have to write my equation for this table. So let's see what we have here. So if I pick any two ordered pairs I want, remember to find my slope, I subtract my y values, and I divide it by subtracting my x values. So I would have 0 minus 1 and negative 5 minus negative 3. 0 minus 1 is negative 1. Negative 5, and remember you can do same, change, change. So negative 5 plus 3 is a negative 2. When I divide those, I would get a 0.5 or 1/2. So far this equation is y equals 0.5x. I have to find my y-intercept. So remember, 0 is halfway in between -1 and +1. So halfway in between 2 and 3 is 2.5. That's my y-intercept. So I'm just going to write this at the top. So we have function f's equation, y equals 0.5x plus 2.5. And now we're going to compare them. So I would say that, my slope, if I was just comparing my slope, I would say that function e was greater than function f, because 1, remember, if you do not see a coefficient in front of your variable, it's assumed to be a 1. 1 is greater than the slope of function f, which was only 1/2 or 0.5. If I was comparing my y-intercepts, function f's is greater than function e, because function f's y-intercept was 2.5, which was greater than function e's of -5. All right, I want you to try B and C on your own, and when you're ready to check your answers, please press play. All right, so if we're looking at part B, my equation for function B is y equals -2.5x plus 2. Function K's equation was given, so it says which function has a larger y-intercept? Well, +2 is greater than -2, so function B would have worked for the first part. Which function has a larger slope? It would have been function K, because 2.5 is larger than -2.5. Part C, my equation for the table was y equals 1/3 x plus 4. Function K, my equation, y equals 1/4 x plus 3. So the first question says, which has a smaller rate of change, which is also known as your slope? This would be function K, because 1/4, which is also 0.25, is smaller than 1/3, which is 0.33, repeating. Which has a larger y-intercept? This would be function A, because 4 is larger than 3. So I know this video is quite long. Most of this should have been a review. We just threw in a little bit more of information. I hope you understood it, and if you have questions, please ask your classmates or your teacher. Thank you so much, and have a wonderful day.